Migrating workload from Azure Managed Disks to Pure Storage Cloud Block Store with Cirrus Migrate Cloud. Cirrus Migrate Cloud, CMC, is a patented solution created to help customers move data from anywhere to anywhere. With our integration with Pure Storage, Cirrus Migrate Cloud users can easily migrate any workload from anywhere to their Pure Cloud Block Store or flash array with minimum interaction and interruption. Cirrus Migrate Cloud, a migration-as-a-service solution, works with storage vendors to create purpose-built integrations that not only automate provisioning and configuration steps, but also follows best practices for specific storage products. For this demonstration, we'll be migrating a Windows and a Linux workload from Azure Managed Disk to Pure Cloud Block Store. First, let's briefly go over our demo environment. Here we have a Linux virtual machine and a Windows virtual machine in our Azure subscription. Pure Cloud Block Store is also deployed in the same subscription. This is our Linux host, Linux Demo 1. A 4 GB Azure Premium SSD data disk is attached to it for our demo application. And the Windows host also has a 4 GB Premium SSD data disk. We'll be migrating them to Pure Cloud Block Store, and this is the Pure storage. As you can see, the Windows host and the Linux host are currently not configured in Pure. We'll let the Cirrus Migrate Cloud integration take care of that automatically later. Let's take a look at our Linux host. From the metadata, we can see that this Linux host is in Azure with a 4 GB Premium SSD data disk. This 4 GB data disk is device SDC with an ext4 file system, and it's currently mounted to /application-files. And just like most installations in the cloud, iSCSI initiator software and multipath drivers, which we'll need for Cloud Block Store, are not installed on this system currently. So let's get started with the migration using Cirrus Migrate Cloud. In Cirrus Data Cloud, we already created a project called Pure Storage CBS Migration. We will use this for the rest of the migration demo. Enter the project and click on Migration Hosts. Next, click on Deploy Cirrus Migrate Cloud. Let's deploy CMC on the Linux host first. Click here to copy the installation command for Linux. This same automation-friendly command can be used to register as many hosts as you want for this project. Back at the Linux host, paste the copied command in the shell, and CMC should install and register to Cirrus Data Cloud all by itself. The installation is now complete, so let's go back to Cirrus Data Cloud and verify our Linux virtual machine has been registered to the project. Here we can see that it's an Ubuntu host running in an Azure environment. From the host details, we can see CMC has already discovered the 4 GB Azure volume that's currently mounted to /application-files, along with other system information. Normally, this is the time where we'll head over to the SSH session, remote desktop, or some web portal to properly connect the host to the destination storage. But with Cirrus Migrate Cloud's iSCSI storage integration, you don't have to do that. So let's spend a little time reviewing CMC's automation and integration capabilities. When using Cirrus Migrate Cloud to migrate from any source to an iSCSI storage, with just one click, CMC's integration will automatically scan and detect your host configuration, install iSCSI initiators and multipath drivers if necessary, configure the iSCSI initiator, UDEV settings, and MPIO configuration based on best practices, create host entities on the target storage with proper initiator IQN, automatically allocate destination volumes that match the existing source volumes, map those volumes to the migration target, and identify those volumes based on the storage vendor's specific identification scheme. Without Cirrus Migrate Cloud's integration, users would normally have to manually perform all of these tasks before migration can start, regardless of which migration solution is being used. Back at the demo, let's add the Pure Storage integration to the project. We only have to do this once, no matter how much data we're migrating. Go to the Integration Catalog, scroll down to the iSCSI Storage section, and select Pure Flash Array / Cloud Block Store. Click on Add Integration. Here you'll enter a name, management server address, and your API token. To get your API token, go to Settings on your Pure Storage, click on the Access tab, and under Users, select Show API Token. Copy that and paste it into Cirrus Data Cloud. Let's also select our host for the connectivity test. And we can see that it worked. We can also see that we have connected to Pure Storage successfully, and the name and version are correct. From the Enabled tab under Integrations, you can see that our Pure Storage integration named Azure Demo CBS is created, and now we're ready to migrate. Let's create a migration session. From Migration Sessions, click on New Migration Session. First, select our Linux host, and then Continue. For this demo, we'll be conducting a local migration and data volumes only. Click Continue. We'll be migrating the SDC device, which is the 4 GB Azure Managed Disk that is mounted to /application-files. There are no eligible migration destinations. But since we have the integration set up already, we'll click on Auto Allocate Destination Volumes and let the integration do all the work. Select the integration we previously created. Here we can see the host is not ready for auto allocation because CMC found that the iSCSI initiator is not installed. You can manually configure it, or you can just let Cirrus Data Cloud configure the host for you based on best practices. So let's do that. The host preparation operation has been completed successfully. Let's quickly review what CMC has done to this Linux host. The iSCSI initiator and multipath drivers are now installed. Pure-specific iSCSI and multipath configurations have been added. Additional device rules and configuration are also created automatically based on best practices from Pure Storage. New host entity with this host names and IQN has been created in Pure Storage. The iSCSI initiator is configured, connected to the appropriate data IP, and it successfully discovered the Pure Storage targets. Let's go back to the Linux host and confirm. iSCSI is now installed and connected to Pure Storage. Pure Storage specific UDEV rules are also enabled. Let's also take a look at the Pure Storage. A host with the same name as our Linux host was created automatically, and it already has the correct host IQN entered. If we go back to our host, we can see that it is in fact the correct initiator IQN. Let's continue the auto allocation process and let Cirrus Migrate Cloud do its magic to create and configure the volumes. And it's done. Here we have allocated a volume and connected the host. We found the multipath device, and with just one click, everything is created, configured, and connected. Now let's confirm this on the Pure Storage. A new 4 GB volume is created and mapped to this Linux demo host 1. Back to Linux, here we see that the Pure multipath device is created, and we also have 4 iSCSI sessions automatically created as well. This is configured according to Pure Storage's best practices for an Azure VM of this size and bandwidth. Everything is done. The destination volume is allocated, identified, and paired up with the source volume. Let's continue setting up the migration session. Here you can configure the auto resync to minimize the migration time. Here you can also configure a migration schedule and select your IQOS setting. IQOS is a purpose-built feature that intelligently minimizes the impact of migration, allowing CMC to migrate as fast as possible without impacting production I/O. You can view our other presentations to learn more about IQOS. You can also customize post-synchronization actions such as automatically taking snapshots on the Pure Storage. Let's create the migration session. Migration has now started. From the migration screen, you can monitor the migration performance and other statistics such as data reduction and the data change rate. Please note that due to the limitations of this demo environment, this demo Cloud Block Store instance is actually deployed in a remote location with limited network capability and connected via VPN. Therefore, migration performance in this demo does not reflect actual production use. This is a live migration, so let's go to the source Linux host and generate some changes to the /application-files directory. As you can see, all new writes during migration are detected and registered on our change data map. As we perform more writes to the directory, more new changes are detected. We can always trigger synchronization again until we're ready to cut over. From the Pure Storage dashboard, we can see that data is being migrated into the Cloud Block Store. And the initial synchronization has now completed. Let's proceed with cutover. Let's review the migration cutover process concepts first. The first stage is we need to wait for initial synchronization to complete, which already happened in the demo just now. With Cirrus Migrate Cloud, data is migrating to the storage destination without any application downtime. As soon as the initial synchronization has completed, we can enter C-motion to prepare for cutover. C-motion is a reversible state where Cirrus Migrate Cloud redirects all I/O to the destination volumes without requiring any application downtime. This allows users to immediately benefit from the new storage even before a cutover can be scheduled. With Cirrus Data's patented TDI technology, C-motion transparently redirects production I/O to the destination storage. Next, we'll finalize cutover on Cirrus Data Cloud, and this will make the workload redirection permanent. When it's time for final cutover, we'll briefly bring the application and the migrated source volume offline, complete the migration, and bring the application online again. The production workload will be accessing the destination device directly. Now that we've covered all these steps on performing a Linux local migration cutover, let's go back to the Cirrus Data Cloud portal and complete the cutover process. Click on the Start Guided Cutover Process button. Any applicable cutover guides will be available for selection here. In our case, let's select the Data Volumes Local Migration from Standalone Linux Host Cutover Guide for this scenario. Click on Start Cutover Guide. First, we'll trigger C-motion. Now we're in C-motion. Let's go back to the /application-files directory, and we'll create a file called after C-motion. Let's also generate more changes to the directory. Remember, at this point, the source volume, SDC, which is a Microsoft disk, is still mounted and live. But from I/O stats, we can see DM0 is where the I/O is, and SDC is totally quiet. This can also be confirmed from the Pure Storage dashboard. As we can see, all new I/O is coming to Pure Storage directly once we're in C-motion. Back to our cutover guide. Since this is a demo, we'll skip this step for mount point checking. At any time, if you're skipping a step, you must provide the reason for the record. This information will appear in your final migration report. You can also find when a cutover step is already performed and who did it and at what time. Remember that C-motion is also reversible. From the change data map, we can see that the changes we just made continue to be tracked. This allows us to revert C-motion and move production back to the original state without requiring a full volume copy. Next, let's finalize cutover. Click on the Finalize Cutover button and continue. Following the recommended steps, we can now briefly unmount the volumes and complete the migration session. After we have completed the migration session, we will simply remount the volumes. And just like that, within a few seconds, /application-files is now mounted from the Pure Storage multipath device directly, and SDC is no longer mounted. And as we can see, the after C-motion file is still in the /application-files, so we can confirm that live changes during migration and after C-motion are all intact. The application is now accessing the Pure Storage directly. Migration and cutover are all complete. Now let's move on to the Windows host. This is our Windows 2019 host called Windows-Demo-1 in the same Azure environment. We have a 4 GB Microsoft Virtual Disk mounted to Drive F, which is an Azure Premium SSD. And just like the Linux host, the iSCSI Initiator software is not running. Now let's go back to Cirrus Data Cloud and deploy Cirrus Migrate Cloud. Just as we did with Linux, we're going to click on Deploy Cirrus Migrate Cloud and copy the installation command, this time for Windows. Paste the command in a PowerShell window, and CMC will install and register to Cirrus Data Cloud all by itself. This same command can also be used in automations to register as many Windows hosts as you need. Once deployed, we can see that the Windows 2019 Server virtual machine in the Azure environment has automatically appeared, and there is our 4 GB Drive F. We're now ready for migration. From Migration Sessions, let's click on New Migration Session. Select the Windows host this time and click Continue. We'll select Local Migration and Data Volumes Only. Click Continue. We'll be migrating the application data Drive F. Once again, there is no eligible destination found. At this moment, Windows is not configured in Pure Storage. We'll let CMC create that for us later. Since we have the integration configured already from the Linux demo, we don't have to do this again. We'll click on Auto Allocate Destination Volumes and let the integration do all the work. Select the Pure integration. Here it says the host is not ready for auto allocation because CMC found that the iSCSI Initiator is not enabled. You can manually configure it, or you can just let Cirrus Data Cloud configure the Windows host for you based on best practices. So let's do that. And now it's complete. We've enabled MPIO, we've enabled iSCSI Initiator, and we've created our Initiator IQN and prepared the host with the same IQN in Pure Storage. From the Pure Storage dashboard, here's our Windows host, and the IQN has already been added. Back at the Windows host, if we go to the iSCSI Initiator, we can see that the Pure Storage target has already been discovered. From the Windows MPIO settings, we can also see our Pure Storage inquiry string has been added to the configuration. So let's continue and allocate the volumes. Allocation has completed successfully. We've now allocated the volume, logged into the iSCSI target, and found the Pure Array system device. Let's go to Pure Storage and confirm. Here on Windows Demo 1, a 4 GB drive was created automatically. Back to Windows, this is the 4 GB disk, which is a Pure Flash Array multipath device. We'll be migrating from this disk to this disk. The devices are already paired in Cirrus Data Cloud. We're migrating Drive F, application-data, to the new Pure Flash Array iSCSI volume. We'll repeat the process we used for Linux for the migration parameters. Migration has now started. From the migration screen, you can monitor the migration performance and other statistics, such as data reduction and the data change rate. This is a live migration, so let's go to the Windows host and generate some changes to Drive F. As you can see, all new writes during migration are detected, and they appear on the change data map. As we copy more files, more new writes are detected. We can always trigger synchronization again until we're ready to cutover. The initial synchronization is complete, so let's proceed with cutover. Click on the Start Guided Cutover Process button. Any applicable cutover guides will be available for selection here. In our case, let's select the Data Volumes Local Migration from Windows Host cutover guide for this scenario. Click on Start Cutover Guide. The first step is to enter cMotion. Click on Trigger cMotion. cMotion is a reversible state where CMC will redirect all I/O to the destination volume immediately without requiring any application downtime. This allows users to immediately benefit from the new storage even before a cutover can be scheduled. As we did with the Linux demo, let's create a new file called after_cmotion. We'll later confirm that this change did go to the destination storage directly. Let's continue with Cutover. We will finalize Cutover and follow the instructions to briefly bring the volumes offline, complete the migration session, and then rescan the Windows storage configuration. Right-click on Disk Management and select Rescan Disks. Drive F is now mounted from the Pure Cloud Block Store disk. Let's open this and check. And we can see the after_cmotion file is there too. Just like that, within a few seconds, the production application is now running on the destination Pure storage. Migration is now complete. You can also generate a migration report that includes detailed information about the migration operation. You can view or print it out for a permanent record at any time. If you need support, you can visit Cirrus Data's Customer Center by clicking the Help button at the bottom right in Cirrus Data Cloud to bring up the Customer Center Support and Knowledge Base panel anytime. And this concludes the demo. We've successfully used Cirrus Migrate Cloud to configure the host, configure the Pure Cloud Block Store, allocate and discover new storage, and most importantly, migrate the data from Azure Managed Disk to Pure Storage Cloud Block Store without any impact to production.